All right. Hey, guys. Hey, welcome to my talk. First, I'd like to thank Unity for having me here. It's a great honor to be here. My name is Shrenik Sadalgi. I lead engineering on Wayfair Next. Wayfair Next is a team at Wayfair that is trying to figure out next-generation experiences in augmented reality and virtual reality. We're trying to help our customers better visualize products. So in this talk, I'm going to talk about why we ventured into this space, how we're actually producing this content and solving problems in this space. But first, I'd like to talk about Wayfair itself. Like, how many of you know about Wayfair? Just show of hands. That's good. Like every time I ask that, I always see like more hands go up. So I think that's good. We're doing something. We're doing something right then. So Wayfair is basically one of the world's largest online destinations for home furnishings and decor. Many of you don't know this, but it was actually established in 2002 by our co-founders, Steve Conine and Neeraj Shah. So back then, they had a bunch of microsites that actually sold like very niche products like racksandstands.com or hotplates.com or everygrandfatherclock.com. And in 2012, they actually unified all of these sites into one brand called Wayfair. Since then, we've just been gaining momentum. And today, we have around 5,000 employees. We made around $2 billion last year in net revenue. We have around 5.5 million customers, and we actually sell products in 6 countries. So we have a really, really large selection of products, right? We have, in fact, it's like around a little over 7 million products that we have online. So we're really becoming like all things home, I would say. Last year, we were named the Internet Retailer of the Year, and we beat Amazon and Etsy. But the challenge is that like we're actually only online, and we do not have any brick-and-mortar stores, right? So we're always trying to find ways to improve customer experience, like bridging that gap between what you see online on a 2D web screen and the actual product that you get delivered home. So it's actually ingrained in our culture. So we want to keep like hacking away at different solutions and come up with innovative solutions to actually bridge that gap. So when customers buy products from our website, right, so we want them to feel very confident about their purchase. We want to make them happy. Because we believe that purchasing stuff for your home is actually a very emotional purchase, right? So we need to inspire. We want to make customers feel good about what they're buying. And one of the ways to do that is actually using lifestyle imagery like this, right? So here you can see like products are in context. So this looks like a Brooklyn loft or something, or a loft in Los Angeles. But the thing is that the room actually evokes a feeling, right? We want it to appeal to you. This may not be your style, right? But like, what about something like this? Like, this could maybe appeal to you. Or something like this, right? But what's new here, though? Like, these are just like, these look like well-crafted photographs. That's a part of a product catalog, right? But that's not true. So these are actually 2D renders using Max and V-Ray, right? So I may be preaching to the choir here because like you guys are all like 3D professionals and you do this like day in and day out. But the rendering quality has got so realistic these days that it's very tough to tell the difference between a photograph and a 2D render, right? So this is actually saving us a lot of time, a lot of effort, which means that's reducing cost. And we can actually reuse the models that we have here to re-render this particular image in different scenes, like different settings. We can actually personalize an experience for a customer. So let's say somebody likes contemporary furniture versus somebody else who likes modern furniture, right? Traditional furniture. You can actually render out the product in these different environments and make it personal for the user. But what may pique your interest here is you can imagine an immersive experience where, say, in this case, like you're actually sitting at a patio and redesigning your entire patio, right? So this is a very immersive experience where we're going to use like virtual reality, and we've realized that VR is like the new medium. It has a lot of potential to be the next shopping platform for furniture. So I wanted to show you a quick video on patio playground. So we don't actually deliver by drone, just in case like you were confused. But at the same time, like we actually want to be practical as well, and that's where like augmented reality comes in. So for us, I think augmented reality means practicality, and virtual reality means inspiration, right? So what if I could actually render products in my room before I buy it? So can I actually answer questions for a customer like, will this fit in my space? Will this actually match the rest of my environment? So I want to show you a small video about where I'm trying to shop for bar stools for my new bar table. So this is work that we did on Google Tango. It's an app that we call Wayfair View, where you can actually see furniture in your room before you buy it. So I'm just searching for bar stools here. So I like that particular one. I'm going to try it out. So I just tap somewhere in my space, and it actually renders out. And then you can, thank you. That's an actual loading progress bar. That's like indicating the progress of the download. So yeah, so I'm looking at that bar stool. I'm like, OK, that looks pretty decent. So, but I want to try out different options, right? So I'm going to search for other bar stools as well. There's nothing here in these featured products. So I'm going to actually do a search. So I'm just searching for stools here. And I'm trying to find something that I like. And I'm looking for something wooden that's more traditional. So I'm like, oh, there it is. There's something there. So I'm going to try that out. And now I can actually like move it around, adjust it a little bit so that I can compare the two bar stools. And this is rendered at 1:1 scale. So that's the actual size of the product. So it's answering questions like, will this actually fit like this? Is this good for the height of the bar table that I have? Does it actually match the rest of my space? So thinking about all of these different compelling cases that use 3D models to improve customer experience, right? We actually went ahead and created a team called Wayfair Next. So that's when Wayfair Next was born. This happened last year, last November. So Wayfair Next is actually a small team at Wayfair. Like we're a 7-member Tiger team, and we're trying to figure out like what the next generation of experiences are going to look like for our customers. So we've had a very busy year. We've been creating all these different apps. So the first one that you see on the left is Wayfair View. That's the one that you just saw. So that actually is an Android application that runs on Google Tango, and we released that in June. The next thing is Wayfair Patio Playground. That's an experience for the Oculus Rift, where you can rearrange furniture at a patio. That was in July. And the next product that we have is the Model API. So I'm going to talk about that in detail later. But that's basically an API where we can actually share our models to the developer community. That happened last month. And the last thing, I'm not going to talk about it here. It's just like a teaser for next week. Next week is when we're launching another application. So stay tuned for that. But so all of this stuff is actually what's common. Like, I mean, all of these things are actually powered by 3D models, right? So that's where the power of these apps lie. Like, it's the content, right? So we currently have around 10,000 models in our catalog. So 10,000 products have these 3D models. And our product is like, we have around 7 million products in our catalog. So you can see that like it's a very, very, very small percentage. I don't know if you can see it on the screen, but it's a very small percentage of the number of products that we have in our catalog. So I want to start talking about a little bit about how we're actually creating these 3D models and how we can catch up with the rest of, how do we actually digitize the rest of our catalog. So we have two basic approaches here, right? One is hand modeling. And by hand modeling, I mean that an artist is actually like modeling the product in like some 3D tool, using 3D tools like 3ds Max. The other way of modeling is 3D scanning, where we're actually scanning a physical product and converting that into a 3D model somehow, right? So both of these approaches are good. I'm going to talk about the pros and cons of them very shortly. But quickly, I want to show you like the lab that we have in Boston. So we're headquartered in Boston. And many of you are familiar with this process here. So basically, this is photogrammetry. And we place the product on a turntable. And we turn the product every 5 degrees and capture a set of photographs from different angles. And we do that repeatedly. We turn the product over. And we basically eventually get a large number of photographs for that product captured in a very structured manner. And then we can actually convert that, use software to actually convert that into a 3D model. Right? So this integrates very well with a photography workflow. So you can imagine having this set up in a studio, right? Either at one of Wayfair studios or one of Wayfair suppliers' studios. So this is a good solution. This is really good. But the thing is, there are some challenges, right? This is an example of the scan of Jeffrey the giraffe. Jeffrey the giraffe is like our team mascot of sorts. So this is, again, like a 2D render using Max and V-Ray, but the model was actually scanned from the real giraffe itself. So scanning is great, right? But there are certain challenges. So it's very tough to actually scan shiny, glossy, or like stuff like glass. Okay, we haven't solved that yet. It's also very tough to scan products with holes in them. So if you have a chair or something that has a lot of holes in, like carving and stuff like that, it's tough to scan that. You also need the physical product in order to scan something, which means like you have to get the supplier to kind of ship the product to your studio, or basically there's some shipping time involved, right? So hand modeling, on the other hand, like it's for simple geometry, right? It's actually easy for an artist to create that cabinet on the left. But that bench on the right, like it's going to take an artist like a lot longer to actually hand model that because of the intricate details. Or the giraffe, right? It's very tough to get that done accurately. So we're actually figuring out which products work well for each of these workflows, and we're using a mix of both. So now we can have a look at the model pipeline itself. So where do we start? So we start from the actual product that we have online. So somebody at Wayfair identifies which products are getting 3D modeled. And once you identify that, we actually have an offshore team of artists. And they are assigned one of these products to be modeled. So we send them a lot of reference photography. We send them dimensions. And they model the stuff for us. And then they send it back. So when they send it back, we have to actually verify that the models are accurate. So what we do is we compare the actual supplier-supplied images to the 2D renders of the model that came in. We also compare the dimensions. So I'm just going to show you a screen grab here of an internal website that we use in order to manage this process. So this is kind of internal QA of sorts. So you see the supplier images on the top. You see dimensions being compared from, calculated from the model and calculated from the supplier information. And these are actual 2D renders of the product from different angles, and we can compare it. If there are some discrepancies, we kind of use a commenting system of sorts to communicate with the modeler and tell them what's wrong or what's right about it. And eventually, after a bunch of iterations, we actually get a very accurate model. So this is good for 2D renders, right? So we use 3ds Max and the V-Ray workflow for the renders. So that's great for 2D renders. But what about game-ready assets for our AR and VR apps? So Max files, I guess, are not that portable. So we thought we'll use a universally accepted format like FBX. Since it's easier to manage, you can actually embed textures in an FBX file, and it's basically one file that you need to deal with. But at the same time, we actually need to convert the V-Ray materials into non-V-Ray materials, right? So that Unity's physically based rendering system can actually handle that, can actually render it correctly. So in order to do that, we actually wrote a bunch of Max scripts. So what we do is we're actually we remove a bunch of unnecessary elements. We give a little bit of structure to the hierarchy, which means that the models are coming in, and they need not be consistent, right? There are lots of modelers all around the world helping us out for this. So there's not that much consistency amongst the hierarchy of the geometry. So we want to kind of structure that a bit. We also try to divide the meshes by materials. So we try to create one mesh for each material that's used in the model. So in our case, typically it's around maybe 3 to 4 materials per product, right? So we try to do that. We also give the meshes names with special meaning. I'll talk about that a little later. So we try to encode some information into the mesh names itself. We're also trying to create the equivalent like V-Ray materials, like take the properties from the V-Ray materials and apply them into regular materials so that Unity can kind of render them. We also set like the pivot. So for example, in this case, like if it's a cabinet that's going to be on the floor, we set the pivot to be at the lower center of the product so that we can kind of rotate it around the floor. If it's a pendant light, then we put it in the top center. If it's walls, cones, or something like that, it'll be somewhere on the side. Right. So we also see like this is the this is the shadow plane and ambient occlusion plane that we actually render out for each product so that we can show some shadows on the floor in order to optimize, like, so that we don't have to use like real-time lighting in Unity. Since most of our like products are actually, most of our apps work on mobile. So the other thing that we do is actually we create a JSON material map. So what I mean by that is we basically take all the materials that we have in the FBX file, and we try to represent that in JSON. So what we do is, so that's basically a mesh name, sorry, the material name, and what kind of texture. So it's a diffuse texture, and the name of the texture itself. So the reason we do that is because you could have some issues while importing the FBX into Unity. I don't know if people have faced that or not, but this is kind of a fail-safe way. Like we fall back to this. We refer to this in whenever we know that there's an issue. So we're kind of forcefully importing textures in Unity using this information. So now that we have an FBX file and we have a JSON material map, we take that combination and import that into Unity. So how do we do that? So all the stuff that you're seeing right now, they're all kind of they all run through run as Python scripts. So it's kind of you can kind of run the entire thing as a headless on a headless node in a farm or something like that. So you can actually crunch away, create these models at in like very short periods of time at scale. So there's a small snippet there of Python code where I'm actually like just launching Unity from the command line in a headless manner. So what I do is we basically create a temporary project. We copy over like this little editor script that we wrote for importing FBX files. And what that script does is it actually creates a bounding box. It uses a box collider to just like create a bounding box for each product. It also uses the special encoding that we have in the material names and in the mesh names and assigns like materials. It actually creates materials on the fly and uses those properties and sets them for each material in the FBX file. And we also we create some bundling scripts on the fly and we copy that over as well. So now you have this temporary project that has all the stuff that you need, right? We also have some shaders that we're using. I can talk about that a little later. Then what we do is we copy the FBX file over into that temporary project folder. Okay. Once we do that, the next thing we do is we actually reopen the project. As soon as you reopen the project and launch Unity, the FBX file starts importing. Okay. So, and we quit immediately after that. So we have launched Unity twice and we quit it twice. And by this time, that project has an FBX file that's been imported. The next thing we do is we basically name the asset. So give the FBX file a simple name, like maybe use the same SKU, a unique ID for each product. And we actually write like a little static function on a class that actually exports the asset bundles. So we're using asset bundles to actually serve these models as game-ready assets over the wire. And then finally, what we do is we again like just call that static function. That's the last line that you see there. We just call the static function from the command line while we launch Unity. So you can do that. So what it does is the third time this Unity is being launched, it actually exports the asset bundles. And now we're kind of done, right? Because we actually have the asset bundles in some directory. We take that and we kind of upload it to our servers. I can show you a quick video of the script running. I just wanted to show you like the time that it takes for this stuff to happen. You saw earlier like how much time the max script took, and then this is probably going to take another like 20 seconds or so. So it imports the file, and it's going to create the asset bundles. So overall, I think that we can actually create game-ready assets from a source max file within like 5 minutes or so, and have that uploaded to our server. So as soon as we upload to our server, it just gets indexed by our search technology, and then these products are actually available on in all of our apps. Right. So this is kind of done. So that's the time it took to actually build the bundles. Right. So now I guess I'm going to talk a little bit about like the encoding that we use on the materials. So you see there, like it says spec is like a hex color there, and then like an opacity right after that. So we're actually encoding these kind of properties into the material names so that we can actually, when creating these materials in our FBX editor script, we can actually assign these properties. So we're doing this particularly for specular information, because I think that for diffuse, like we found that there's never been any issues, or it's pretty reliable to actually get diffuse information from the FBX file into Unity. But for specularity, we've had some issues, so this is what we kind of use as a workaround. And in order to handle like transparency, like for glass and stuff, we actually use we encode that into the mesh name. So you can see there's something called cleared obj_0_98 point something. So that indicates that that mesh is transparent, and it's probably glass with a 98% transparency. And for opaque materials, we just say not clear. So we end up using two basic shaders, like one for transparent and one for opaque, right? And these are like Wayfair shaders, but they're just like extensions of the Unity standard specular shader. The other thing that we do here is actually encode versioning at the same time. This is like poor man's versioning. So this is V5, which means this is like our 5th version, I guess. So we started off initially with creating like V-Ray maps, like V-Ray texture maps. So we were trying to bake V-Ray texture maps into the FBX file itself, and we realized that was taking too long. Firstly, in the export process, and on the mobile devices itself, like it didn't perform that well with these big textures on it. So this is something that we kind of figured out, because you don't need like a texture to actually represent, let's say, metal, for example, right? So like metal legs, or a plain like top, like, or plastic screws, and like small metal buttons. So we can actually just create these nice materials without any textures for that, with good properties. So once the bundles are created, we actually upload them to our servers, like I said before, and they just show up in the app. So here you can see like this is some sample JSON that our servers return, and that's like a SKU with a bunch of information there, like it's an FBX file, the web asset bundle, the Windows asset bundle, and Android asset bundle. So we do not use the manifest file in any way for these asset bundles. So each product is one asset bundle. So it's like a 1:1 between products and asset bundles. So we don't care about the manifest. We don't care about any of that stuff. We just package it up and we upload it to our servers, and we basically load the asset bundles on the fly on our devices. And that's what you see when that loading progress bar, the box filling up. That's basically the download progress for downloading the asset bundle. So in order to actually test this kind of game-ready asset, so we were testing 2D renders earlier, right? So in order to test the game-ready asset, we actually have a simple QA app where, so what this does is basically you enter a SKU in, and it talks to a server, gets the asset bundle, and it actually shows you the product. So this can be very useful, because we want to embed this into that QA page that you saw earlier, because this helps us test problems in that workflow of exporting to FBX and importing the FBX, because there can be problems there, right? So this kind of lets us know if there was an issue. So you can see how we're using the box collider to actually draw that little box around the product and then render dimensions on it. You can also see the shadow plane at the bottom of the product. And that's what you saw that was baking earlier when you saw Max going through its script. Here you can see the glass, for example. So it's not bad. Like, I mean, it's not. This can be improved, but like I guess we're just going about it in a very iterative manner. But the important thing to note here is that it's the content that's key, right? The content is where the power is. So we're trying to figure out how you as developers can actually use this. We want to empower developers to actually use these models in your experiences. So what we've done is actually we've launched a 3D model API that lets you do two things, right? One is you can actually fetch products for a particular class, let's say. In this case, it's coffee tables. Fetch page 1 of that, and it will kind of list out all the different products that we have that have 3D models for that particular class. And that comes along with simple basic information like the name of the product, price, description, the actual the image, and that can just keep getting enhanced, like reviews and stuff like that. So this is like a very basic version. This is like V1 of the model API. So that's one endpoint, right? It's just fetch product information. The second endpoint is actually getting the real models for the product itself. So once you have the SKU that you're interested in, you basically make another call and you can get the SKU. So what you saw earlier here, so that's basically a sample Unity app that we can publish to the asset store that has like reference code, has our shaders, and like you can basically start you can use that as your starting point to create an app where you can embed our models in your app. So just wanted to show you like quickly how to query the API itself. So this is the first endpoint where we're actually getting product information. So you'll see you'll get like a bunch of JSON back. It has SKU, product name, price, description, and it also actually has this interesting thing. So it's got like this link that takes you back to the product's listing on Wayfair, which means that somebody can actually purchase the product depending on how you code this in. You can actually get someone to go to Wayfair and buy this product, and then we're still trying to figure this out. But then the idea is to get royalty based on any customer purchases that arise from your app. So you can imagine a game or experience with models blending in very naturally. So imagine you had an experience that or a game that you're kind of working on, right? But then use our 3D models to actually populate the game, because you need furniture to make something look more real or more natural. I mean, depending on the category of the game. So you can actually not spend time trying to create those assets and just use these things. And at the same time, if once we figure out how to brand these products, let's say you're hanging out in a social space in VR, right? And that's a cafe or something. And the cafe has these cool bar stools or couches and stuff. And then you realize that that's actually a real product that you can buy from somewhere. It's not something that an artist just made. It's kind of an actual real thing that you can buy. So this kind of opens up all of these possibilities, right, for advertising in VR. Or if you have an interior decoration app, then you want to probably use these models to kind of to get more people visiting your app. It could be real estate walkthroughs where you're trying to actually showcase a space in VR using and actually embed real furniture in it. It could be games, right? So I guess what I want to leave you here with is this could actually be used in your game. So we would love to hear any feedback that you have on the API itself. You're welcome to use it. It's in private beta, so you have to just kind of send us an email, and then you have to sign some legal agreements, and then once you're done with that, you basically get an API key that you can use to access the model API. So yeah, that's all I have today. So if you have any questions, you can send an email to next3dapi@wayfair.com in order to get access to the API. Or if you're just generally curious about what we're doing, then next@wayfair.com is also a good email address to send an email to. All right, thank you.